There's a lot more going on inside of reactions than just molecules breaking bonds and forming bonds. And so what we're going to do is in this chapter is look at that kind of thing. The first thing that we're going to look at is energy. And most of you are somewhat familiar with energy. There's two kinds: kinetic energy, which is the energy of motion. And in chemistry, we usually detect this with heat, because the faster molecules move, the hotter it is. The colder it is, the slower they are. And then we have potential energy. Potential energy is stored energy. And in molecules, potential energy is stored in bonds. So we've got the motion of molecules and the bonds of molecules, and the energy can be converted from one to the other. So in a chemical reaction, you might have bond energy changed into the motion of molecules, so things get hotter, or you might have the motion of molecules converted into bond energy, so the molecules get colder. The key thing to remember here is that the amount of energy that you have always is the same. There is no loss of energy or gain of energy. It's just it's transformed from one place to another. So if temperature goes up, that means that the potential energy stored in the bonds has gone down, etc. We have energy units. You probably are very familiar with calorie because you hear about that being in foods, although it's slightly different, which I'll explain to you in a minute. And there's another one called joules, and these are the two major ways of measuring energy. A calorie is defined by the amount of heat that it takes for 1 gram of water, liquid water, to be warmed by 1 degree Celsius. A joule is actually a physics definition, and it comes from mass and how fast it's moving and things like that. But we use it in chemistry all the time. The relationship is a calorie is equal to 4.184 joules. You can use that in conversions. Not a big deal. You should be able to do conversions very easily by now. We also use the metric system with these base units. So you can have kilojoules, you can have millijoules, you can have kilocalories, and you can have microcalories. All of that works the same way as we did with the metric system. Be sure to practice any problems that you might encounter in your book that have to do with conversions, because you lose that skill unless you practice it once in a while. Now, when we look at food, we often will say that food has certain calories. Well, that's the energy stored in that food for you to use for movement or building molecules, doing other metabolic processes. And so we have amounts of energy stored in these foods, and typically the major nutrients are fat, carbohydrate, and protein. Now, this calorie that is in food is not the same as a calorie used to heat 1 gram of water 1 degree Celsius. This is actually a kilocalorie, and it is written with a capital C. So a little letter C is the one is a calorie, and when you write it with a capital letter C, it's actually a kilocalorie, not a true calorie. Now, roughly a gram of fat has 9 kilocalories, or big C calories, of energy in it. And a gram of carbohydrate or a gram of protein has 4 kilocalories, or big C calories, stored in it. And this energy is stored in the bonds of these molecules. So if you don't take those molecules and break them down and grab the energy that's in them and use it for movement or for building bigger molecules, what happens is it takes those molecules and stores them either as those molecules or as other molecules somewhere in your body. So it truly is, as is said many places, energy in, energy out. There's a balance between that. If you don't use the bond energy, then you store that molecule. And so it's all a balance of energy. So remembering the caloric values given in the previous slide, how much energy is in one little French fry containing 1 gram of fat and 3 grams of carbohydrates? Well, this basically is a conversion problem. So what do? We set it up to do a conversion. Now, you can't do it all in one step. You have to do each one separately. It's 1 gram of fat and 3 grams of carbohydrate. Remembering that 1 gram of fat has 1 kilocalorie or food calorie per gram, you can convert. You're basically doing a gram to calorie conversion. And to take 3 grams of carbohydrate, you use the different relationship, which is 1 gram is 4 kilocalories, which gives you 12 calories. Altogether, you sum these two together and you get 21 kilocalories or food calories. Here's another one for you to try. Well, this one's a little bit harder. The person is using 1,620 calories in a day to move and maintain bodily functions and consumes this much food. So how many grams of fat are going to be stored on the body? Well, if we look at this, we just have to take each one of these and convert it to calories. So 78 grams of fat, 240 grams carbohydrate, and 197 grams of protein. You do the conversion to calories, and you see that 1 gram of fat gives you 9 calories, and the protein and carbohydrate are both 4 calories apiece. Now that's a total number of calories that the person has consumed in their food. So what is this? This is 2,450 total calories. How many calories did they use moving around and maintaining bodily functions? Well, it's the difference between what they ate and how they moved. That gave you 830 calories. This now can be converted to the amount of fat that would be stored on your body. So 830 converted back to grams gives you 92 grams of fat.